For this question, we are to identify the correct vector addition diagram for an object in equilibrium. So we must know that at equilibrium, by Newton's second law, the resultant force is zero. So for a vector diagram, this will show up in the form of a zero resultant force. What does a zero resultant force mean? It means that the ending point of the tip to tail method will be at the starting point. Some of us describe this as a closed diagram, where the starting point and the ending point is the same. So with this, the answer is C. We can just start with a random vector to start adding the vectors. So starting point, and notice that the arrows direction flow continuously in one direction, and ultimately the last vector will end at the starting point. So this tells us that the resultant force is zero. Now I will also go through why the other options are wrong. So for option A and B, there shouldn't be any resultant force because the question tells us that we want a vector diagram that represents an object in equilibrium having zero resultant force. In addition, if you trace the direction of arrows, you will notice that for option A and B, the arrow direction doesn't flow in one continuous direction. For option D, that is not the tip to tail method. The arrow direction doesn't flow. You could have been going up in this direction, and you can continue adding the second vector. But when it comes to a third vector, this is the error already. If indeed that is the third vector to add, we should have continued on the direction in this way. Okay, so that's the reason why option A, B, and D are wrong options.